If you like my dad's videos, please subscribe to QA Insights channel.
Welcome to Learn Chaos Engineering series. In last video, we have seen about what is chaos engineering, its principles, and what is the difference between the performance engineering and chaos engineering. Starting this video onwards, we are going to learn about more solutions and tools which will be very helpful to implement the chaos practices in your organization. To begin with, let us learn about LitmusChaos. First, we are going to see the tools which are in the CNCF landscape, and then we can see other tools as well. To begin with, LitmusChaos. So LitmusChaos is one of the CNCF incubation project under observability and analysis category. Recently, it got acquired by Harness, but initially it got created by Chaos Native. If you go to CNCF landscape, you can see this list, and definitely keep an eye on this CNCF landscape, which will be very helpful to get to know more about trends. So LitmusChaos 2.0 features. So these are the core features of LitmusChaos. The main feature here is the LitmusChaos workflows. So here, if you see, this feature is one of the core implementation in 2.0. Initially, there was no such matured way of doing the chaos, but in 2.0, you have the chaos workflows. So inside this chaos workflows, you define what experiments you are going to carry out, and then you can configure its values. And also you can do a lot of things like YAML manifest, and then you can declare some duration between the chaos and so on. And also they have introduced the teams feature. So if you want something matured way of handling your team, definitely you can check it out, the teams feature. And of course it supports GitOps, and then you can implement the LitmusChaos per organization using the cross-cloud implementation. And also it has one of the feature called Chaos Hubs. So this is the like a app store. You can think of like an app store where you can copy the experiments from either from public repository or from your private repository. So this will have more than 40 plus experiments which we are going to see. And also it comes with Litmus CLI and intuitive GUI. And of course it is scalable because it resides in your Kubernetes cluster, and integrated and interleaved monitoring feature which will help you to monitor your LitmusChaos UI. So these are the core features. So in this demo, we are going to see about the Litmus Cloud feature. This is the product I'm going to use. But if you want to install as a self-hosted in your local Kubernetes, of course you can go with the self-hosted option. To install the LitmusChaos, you can install the Kubernetes 1.17 or later version, and you need the PV of 20 GB. So this is the prerequisites in case if you are going with the self-hosted. But for the SaaS version, I will leave the link in the description. You can sign up for free, and then you can just try it out the Litmus Cloud feature. Okay, now let us talk about the LitmusChaos architecture. It is a little bit complex if you try to understand each component, but I'll try to explain on a very high level so that you can concentrate on creating the experiments and test your resiliency for your application under test. So here in this architecture, on the left side, we have the target audience. It could be an SREs, developers, or performance engineers, or performance testers, or QA guys who will launch the Chaos UI, LitmusChaos UI, and then they create the experiments. So in this diagram, we have the experiments for WordPress, and then we have the pod network latency experiment here, and then we have the MySQL experiment. So this experiment will be created using the chaos control plane. So this is the control plane where your LitmusChaos resides. So this is the Kubernetes infrastructure. You need to have a Kubernetes cluster to install these components. So this will run the UI. This is the chaos center where you log in, you create multiple experiments, you schedule it, you see analytics, etc. And then it will run 3 pods. auth server for authentication purpose, MongoDB to store the data, and GraphQL server to interact with the chaos execution plane. So this Kubernetes cluster, the blue color rectangle, this is the chaos control plane. So chaos control plane consists of these pods which will run on the Kubernetes cluster. So once you have this up and running, if you want to test your application, so your application could be running in either in Kubernetes or it could be running in bare metal or AWS or Azure or your favorite cloud. So whenever you want to test your application, you need to have something like an agent. So whenever you install the chaos control plane here, you will get something called self agent. So by default, it will create a self agent. But for your testing purpose, you might need to install the external agent. So the external agent will reside on the chaos execution plane. So inside this chaos execution plane, you will have the Litmus agent infrastructure. So this is your agent, which is external agent basically, which will have the chaos exporter basically to send the data, to store the data to Prometheus. And then you will have something called event tracker. And then you have the chaos agent and workflow controller. So workflow controller and subscriber chaos agent, they will utilize the Kubernetes custom resource definition. So here you have the chaos workflow CR and chaos experiment CR and chaos engine CR. So these are the CRDs, which will be, it's a backbone basically. So these kind of CRs will be very helpful where you can define your experiments, you can run it, and then it will help you to test the resiliency and other factors. So these component, this backend infrastructure will send a load, or it could send some whatever you define in your experiment to the application under test. So this application under test, it could be in your AWS, or it could be bare metal, or it could be some other Kubernetes cluster. So this is the very high level overview about the architecture. So basically you need to install the control plane, and I recommend to install the chaos execution plane for the external agent. And then you can manage your teams, you can create the experiments, making use of the Chaos Hub. So Chaos Hub, it's not shown here, but Chaos Hub is the app store for the Chaos experiments, where you can leverage the YAMLs to run your experiments. So I hope this architecture will give you some idea about the LitmusChaos. So now let us talk about the demo setup. So today we are going to see a demo leveraging the Litmus Cloud. So this Litmus Cloud, it's free to sign up. So this is where we log in into this Litmus Cloud, and then I have installed the external agent here. So external agent is running in AWS Kubernetes. And then I have installed some demo application called Robot Shop within the same AWS Kubernetes. And then we will leverage the Litmus Cloud and Chaos Hub to run the experiments. So to inject the load, I am using JMeter, of course. And JMeter is running in my EC2 box separately. And the results will be published to Influx. And for visualization, I am using Grafana. You can use Prometheus or any other flavor to publish it to the visualization. So now let us see about the experiments, what we are going to do. The first experiment we are going to carry out is pod delete. So we will randomly select some pod from the Robot Shop namespace, and then we will try to delete it. And then let us run the network loss, and then we are going to run the network latency experiment. So pod delete will delete something. A network loss will create some network, the latency, it will be lost completely. And then we are going to simulate some high response time. So these are the three different types of experiments we are going to carry forward in this demo. So please check it out, academy.qainsights.com for more such tutorials. Now, without any further ado, let me launch the Chaos Hub. So this is the Chaos native, the cloud flavor of LitmusChaos. If you want to install on your own Kubernetes cluster, you can of course install, but just for the time's sake, I have signed up for the Litmus cloud. So here, when you log in, this is the home page, you will get it. And by default, I guess you will have something self agent. But for the demonstration purpose, I have installed the dedicated agent, external agent on my EKS cluster. So if you want to connect your agent, you can just click on the connect the agent, and here you can follow the instructions. It's pretty straightforward, nothing fancy, but make sure you have the access key and the secret. If you want, you can generate it using this link. And if you just follow that, it will automatically displays the agents here. So you can use these agents to run your experiments. So now to create the first workflow, I'm going to click on this Litmus workflow here, and then I'm going to click on schedule a workflow. So here it will list out automatically the agents you have installed. So in this case, we have the QA Insights. So just to select the agent and click on next. And here you have 4 options. Either you can create your workflow from the predefined Chaos workflow templates, or you can create from your existing workflow, or you can leverage the Chaos Hub. So this is the app store of Chaos experiments, or you can import your workflow from the manifest. So in this case, I'm going with the Chaos Hub. So just select the Chaos Hub and click on next. And optionally, you can change the workflow name and the description. So I'm going to leave as is, and let me click on next. So here, this is the place where you define your list of experiments one by one, and it will automatically displays the graphical visualization here. To add the experiment, just click on the add a new experiment, and here search for a pod. And in this case, our first experiment is pod delete. So just to select the generic pod delete and click on done. So by default, it will fill out the namespace and application. So to edit this, you have to just click on the pen icon here. So by default, it will autofill the hub name, experiment name, and context name. So I'm going to again leave as is, and I'm going to click on next. So here it will automatically list out your the namespaces. So wherever you installed your Kubernetes agent, LitmusChaos agent, and then it will automatically fetch the details, and it will display the namespace. So in this namespace, I have so in this cluster, I have Litmus and Robot Shop. So we are going to play around with the Robot Shop. So just to select the Robot Shop and select the kind as deployment. So here I'm going to first delete the pod for the cart service. So I have installed the Robot Shop. So Robot Shop leverages the cart service. So we are going to kill this. So once you configure the target application, click on next. And here you can define the steady state. So we are not going to define any steady state, and click on next. And I'm going to run this experiment for about 60 seconds. And then I'm going to keep the other variables as is. And here under the pods affected percentage, I'm going to enter the 80%. Or let us go with say 100% of pods. And I click on finish. And again, repeat the steps for the second experiment and the third experiment. So second experiment is network. So let us search for network loss. Click on done, and click on edit. Again, keep the general as is, and change the namespace Robot Shop and deployment. And we are going to cause the network latency for the say shipping, and click on next. Again next, let us keep this to say 120 seconds, and then let us select the pods affected percentage, say 100%, and click on finish. Again, we are going to create the experiment for the another network flavor, which is the network latency. So this will increase the latency. Again, repeat the steps. Target application should be Robot Shop, and the app label, in this case, I'm going to select the say user, and click on next. And in the tuning, we are going to create the network latency about say 5 seconds, 60 seconds duration, and then we are going to say 100% pod affected percentage, and click on finish. So right now we have, see here, there are around 3 experiments. The first step is to install the experiments here, and then pod delete, network loss, and network latency. So once you're done with here, you can edit the YAML, or you can just proceed with the next step. And here you have to configure the weightage. So probably I can cover this in another video. So basically you need to give some weightage for each experiment, and then it will calculate the resiliency score at the end of the test. And click on next, and we are going to schedule it now. But before I schedule it, I want to show you where we are going to run the experiment. So this is my EC2 box where I am running the JMeter. So this command will kick off the robot shop test execution with the threads 100, and its total duration is 10,000 seconds. Ramp up is 60 seconds. So here I am passing the influx token so that it will publish all the data to the influx database. So now I am going to start this execution, and then I have already configured the Grafana. So now let us open the Grafana here, and let us select, say, last 15 minutes or last 30 minutes. Yeah, last 1 hour you can see this is the number of threads and the number of hits and the average response time. So I'm not creating something very fancy one, just 3 graphs which will explain the concept. So now if I go to, say, past 5 minutes, so now the threads is 38, it is increasing, and of course the average response time and hits per second also, it is increasing. Now let us wait to reach the steady state. So it will reach the steady state within 1 minute. So basically the number of threads which will be running is around actually the 100 threads exactly. And then we can see the steady state by monitoring the average response time and hits. So this will give us some idea about the actual performance of our application. Then we can inject the experiment, and then we can learn the resiliency and other issues in our application. So right now it is running with 100 threads. Now if we go to the EC2 box here, you can see the maximum response time is some 18 seconds. Basically it's very small box, so forget about the response time factor. Let us focus on how we can fail this application. So here it is running with 100 threads, and you can see the average is 409 milliseconds, maximum is 18 seconds, and this is my hits per second. So now what we can do is let us start with the experiment. So let us go back to the Chaos native, LitmusChaos, and I'm going to click on next, and I'm going to start the execution. So once you click on finish, you can go to the workflow, and then you can see the progress here. But I have installed Lens IDE, which will display my EKS. So here, if I select the say Litmus, so this is where the Litmus is running. Number of pods, deployments, daemon sets, stateful sets, everything you can see it in one shot in the overview section. Now if I go to my robot shop, so this is where the robot shop is running. And if you go to pods, you can see these many pods are running and these many deployments are running. So now what will happen, let us monitor the Grafana and also this Chaos native. So right now the experiments are already installed. Now it is about to start the pod delete. So if you click on this entity, it will display the logs. And here you can see the log status and what it is doing. And if we go to this Lens ID also, you can see the events. So this is the event right now, it's happening right now at this moment in my cluster. And if you go to the Grafana thing, here you can see decrease in the hits per second and the response time will increase. So that is what we are going to observe now. So now let us go to the Chaos native, and here you can see it is in progress. And if you go to the Lens IDE, you can see some of the pods will be killed. Here you can see the cart is getting killed, right? So now the pod is gone. So you should see some kind of a increase in the response time for the particular transaction. So here might not be showing it clearly, but it will take some time to propagate because there is some lag between multiple components we are using. So whenever you see something here, it is already might be happened, but it will take some time to reflect here. So here, as I mentioned here, see, there's a drop here. So there is a drop in the response time. And let us wait. So now the pod delete is done. So let us wait for the complete status for this experiment. So now the pod delete is done, as you see here. Now there is a pod network loss experiment is running. So now if you go to Linux IDE, you can see the pods which are up and running in the Litmus workspace. So this is where your see pod delete and pod network loss. So all the pods will be spinned up in the Litmus namespace. So now if I go to the Grafana, here you can see there is a elevation in the response time and a decrease in the hits per second, because the pod network loss experiment is running now. So now you can clearly see what's happening in your application and how your application behaves if this happens in your production. So this is where the chaos experiments are coming into picture. Now let us wait for the pod network loss, and then it will create the next experiment. See, now the network loss has completely done. As you see, it dropped to 0. So basically you will see some gap because the pod network has lost. So you will see nothing for a few moments, either in hits or response time. Everything will be 0 now. Okay, now pod network loss experiment is done. Now it is running the pod network latency. So in this network latency experiment, you can see the elevated response time in the average response time graph here. And also it will impact the other factors like hits per second and other performance metrics. Now let us wait for a few moments and let us see the average response time. Okay, now the pod network latency also it is done. Now the last step is it is reverting all the chaos experiments. So now this also it's completed. Now if I go to the whole page here, the table view, you can see your status. And if you want to download your results, you can download your logs and the chaos results. And if you go to home page, you can see the status. Now if you click on the overall, again you will get the same view. Okay, now let us quickly analyze the Grafana results. So this is our whole duration of our test. So this is where we have started here. So in this region, there is a ramp up basically for about 1 minute. And then we have the pod delete. So once the pod delete happening, then there is some a decrease in the response time, overall response time. You can observe it here. And then after a few moments, we have the the network loss basically. So this is where everything got blacked out and everything dropped to 0. And after a few moments, we got the network latency. So this is where you can see the increased response time. And after that, we have the complete steady state because no experiments are running. So you have to just analyze into 3 phases. One is before the experiment, and during the experiment, and after the experiment. So while analyzing these 3 phases, you can easily identify the resiliency and the performance and other aspects when you do the chaos engineering. So this video, I hope, will help you to get started with chaos engineering. Of course, there are a lot of things you can do. You can find the where you can fine tune, you can concentrate on the CPU, you can concentrate on memory. So there are so many factors out there, but we just touch the scratch of chaos engineering using the Litmus chaos solution. And of course, we are always leveraging the open source. And definitely you can try the Litmus chaos cloud flavor so that you can offload the maintaining the Litmus chaos cluster. So thank you for watching. Please sign up at academy.qainsights.com for more such tutorials, and have a good day.
If you like my dad's videos, please subscribe to QA Insights channel.